So let's do a bit of an architectural postmortem. We're going to walk through the structural evolution of AI systems, and specifically how we got from raw, unbounded intelligence to the governed, enterprise-grade infrastructure we have today. And look, this isn't going to be a story about benchmarks or parameter counts. It's about the architectural lessons we learned from a series of pretty critical failures, lessons that forced us to realize how to actually scale autonomous systems safely.
And really, this is the core thesis of this entire explainer. You see, as systems gain the ability to act over time, to use tools, and to actually change things in the real world, the main reason they failed wasn't a lack of reasoning anymore. It was a lack of governance. Suddenly, all that uncoordinated intelligence, it became a huge liability. This realization that raw capability just wasn't enough is what drove the creation of an entirely new architectural layer, the control stack.
And what's interesting is that this created a real paradox. As models got more autonomous and more confident, the systemic risk didn't go down, it actually went up. A more capable agent explores more aggressively, and it generates much more plausible-sounding justifications for doing the wrong thing. This forced a huge shift in our focus. We had to stop asking, how smart is the model, and start asking a much more important question. What is this system actually allowed to do?
All right, so where did we learn this first hard lesson? Well, it came directly from the failure of our very first attempts to put any kind of rules on these systems.
In the early days, we tried to govern these models using natural language instructions right inside the prompt. We were basically asking the model to police itself. And that's just structurally unsound. Prompts are interpreted probabilistically, they're suggestions, not hard constraints, and they're completely invisible to any external audit system. That's a fundamental architectural flaw, right? You can't govern a system with rules that are only visible to the very component you're trying to govern. The clearest proof of this failure was the prompt injection attack. A cleverly crafted input could essentially convince the model to just ignore its original instructions. Think about it. If your security logic is just more text inside the prompt, it can be completely overridden by other text. This wasn't some minor bug. It was a class break, a critical vulnerability that proved the entire idea of in-model security was a dead end.
And this brings us to the key conclusion from that first failure, the real lesson of the postmortem. Persuasion is not a security mechanism. You can't request control, it has to be enforced. This realization is what forced the entire architecture to split in two.
So, this complete failure of prompts led us directly to the foundational architectural principle of modern AI systems, a hard separation of concerns. The solution was to build a firewall between intelligence and authorization. The model, the intelligence component, is responsible for figuring out what could be done. It proposes actions, but a totally separate external authorization system is what determines what may be done. And this is non-negotiable. I mean, a network firewall doesn't ask an application for permission to block a port, right? You can't have a system that both proposes an action and then approves its own proposal. That's not control, that's just self-deception. Okay, so this firewall idea, it wasn't just a concept. It actually required us to build a whole new stack of architectural components designed specifically to enforce it. The very first piece redefined the concept of context. In these agentic systems, context is capability. What an agent can see literally determines what it can think about and what actions it can propose. The old way of prop stuffing, just dumping all available information into the context window, was a massive security risk. So the Model Context Protocol, or MCP, flips this on its head. It treats context as a managed, revocable resource. Access is scoped, and it's delivered through explicit providers. For the first time, this gave us least privilege access for models. All right, so the next layer of control had to tackle tool usage. Every single tool call is a potential side effect. Writing to a database, making an API call. Unchecked tool use led to absolute production disasters, like idempotency failures, where running the same operation twice would cause huge unintended consequences. The solution was to wrap the probabilistic model inside a deterministic shell. This shell treats the model's request to use a tool not as a command but as a proposed contract. The shell validates it, checks permissions, and then executes it in an isolated way, shielding the rest of the system from the model's unpredictable nature. Now, as these agent fleets started to grow, trying to enforce rules on each one individually just fell apart. It didn't scale. This led to a necessary re-centralization of control, borrowing from patterns we already knew, like API gateways and service meshes. And that's where the Universal Control Plane, or UCP, comes in. It acts as a single centralized gateway for all agents.
Every action has to pass through this proxy before it can touch any external system.
And these aren't just suggestions that the model can think about. No, these are hard, infrastructure-level rules. We're talking about things like rate limits and budget caps, permission checks against a real identity system, PII redaction, and compliance with formal policies. The crucial part is that this all happens completely outside the model. A compromised or hallucinating agent simply cannot get around these controls. It just hits the wall of the UCP.
So we've managed to secure the individual agent. But of course, the next challenge was scaling from one agent to a whole fleet of them working together. And that's where we hit the next major failure, coordination just breaking down completely.
The first idea was just to let the agents talk to each other, unstructured natural language conversation. And it was a complete failure. It led to message chaos, role confusion, and totally non-deterministic results. The industry was pretty much forced to adopt formal agent-to-agent, or A2A, protocols. Instead of just chatting, agents advertise their capabilities, they use typed messages, and they follow explicit task lifecycles. Language became the payload for a structured protocol, not the protocol itself. The interaction was now governed by code, not by conversation. And to actually govern these complex interactions, natural language rules were never going to be enough. They're just too ambiguous and impossible to enforce. The solution here was policy as code. All the governance rules, what actions are allowed, escalation paths, budget constraints, are all defined in a declarative version-controlled format. Then these policies are enforced systematically by the universal control plane. The key thing is, an agent doesn't get to interpret the policy. It either complies or its action is just stopped cold. So all of this new architecture, it fundamentally changed the role of human oversight. We basically moved from being in the loop to being on the loop. Humans weren't operators anymore, micromanaging tasks in some chat box. We became governors. The main way humans interact now is through a governance dashboard for defining policy, setting budgets, and approving high-risk escalations. And critically, it's a tool for reviewing immutable audit trails. These trails don't just log what happened, they record the entire chain of intent, the observations, the policies that were evaluated, the decisions that were proposed. This gives you true provenance, an unchangeable record of intent, which is the absolute foundation of accountability in an autonomous system.
Okay, so this all brings us to the final strategic conclusion. Why does this control stack matter beyond just being a cool technical architecture?
Well, it comes down to this. The underlying intelligence models are getting better at a ferocious pace. They're becoming commoditized. An organization can and will swap out one model for a better one. But that governance layer, the permissions, the policies, the budgets, the audit trails that have been so carefully built and validated, that is far more durable.
The true, enduring competitive advantage is no longer in having the smartest model. It's in having the most robust, scalable, and trustworthy control stack. The future of enterprise AI will belong to the systems that can safely govern intelligence at scale. Real power isn't the agent. The power is the control plane that grants the agent its authority to act in the first place.
And that really leaves us with one final question for you to think about. As you design and deploy these systems, where are you building your durable advantage? Is it in that ephemeral intelligence layer that's always changing? Or is it in the enduring governance and control stack that actually makes that intelligence safe enough to use?